So here we go with video number 3. So we were just talking about lionfish and how they have 3 different stages: larvae, juvenile, and adults. And the larvae and juveniles can grow into juveniles and adults. And the juveniles and adults can persist or stay in the same stage for more than one time step of a month. So G for growth, P for persistence, and only adults can reproduce. So only adults have a fecundity, or an arrow going from A to L, or generally from A to whatever the first stage is. So how do we put this into this matrix? Okay, so the easiest thing to put on there first is persistence, because it goes down that main diagonal. So larvae can't persist for more than one time step, but juveniles and adults can, but PL and PA. So larvae to larvae is going to be 0. Juveniles to adults is going to be PL. And adults to adults is going to be PA. Now the next thing we're going to put on here is growth, because that goes on the diagonal just below that main diagonal. So since larvae can grow into juveniles, GL, from larvae to juveniles, it's going to be GL. And juveniles can grow into adults, called GJ. From juveniles to adults is going to be GJ. The next thing is fecundity. Now fecundity always goes in the top row, because it's always the contribution of any stage to that first stage, in this case larvae. Since only adults have a fecundity stage, it's going to be 0 for everything but right here, from adults to larvae. And the other 2 possible transitions are going to be 0. There are 3 possible transitions. Okay, let's try this for another example. And this is for a plant that has seeds, immature plants, and mature plants. It's very similar to the last example. Can you notice what the difference is? So did you notice over here? You can stay a seed for more than one time step. That's the main difference. So again, growth from seeds to immature plants, growth from immature plants to mature plants, persistence in all 3 stages, and fecundity only of mature plants. So F3. In this case, we'll use 1, 2, and 3. So again, how do you put this into the matrix? So this time we'll try doing it a different way. We'll look at the contributions from seeds to the other stages first. So from seeds to seeds is persistence, P1. From seeds to immature plants is growth, G1. From seeds to mature plants never happens. You can't grow from a seed to a mature plant in 1 year for this particular species. So P1, G1, 0. Now how about when we look at immature plants? Can immature plants contribute to seeds? No. They're not reproductively mature yet, so that'll be a 0. However, immature plants can stay immature plants. That's persistence, so P2. And immature plants can grow into mature plants, and that's G2. Now how about mature plants? Mature plants can contribute to seeds. That's what that fecundity F is, or I think in the last slide we called it F3, but whatever. Mature plants can't get smaller or contribute directly to immature plants, so that'll be a 0. So we have an F and a 0. Immature plants can stay mature plants, that's the P3. So there's another model. Now let's try doing this a different way. If we know what the transition matrix is, can we predict what the life cycle diagram should look like? So remember, from is up here, so let's try looking at from stage 1 to the other stages. The stage 1 can't stay in stage 1 for more than 1 year, but it can grow. Oh, okay. No, let's do this a different way. Let's look at the growth first. Which stages grow into the next stage? Well, there's a G1 that's from stage 1 to 2, a G2 that's from stage 2 to stage 3, and a G3 that's from stage 3 to stage 4. So stages 1, 2, and 3 can grow. Yep. Okay, now the next thing, let's look at persistence. Which stages can persist or stay in the same stage for more than one time period? For stage 1, that's 0, so stage 1 can't. But stages 2, 3, and 4 can. So it looks like that. Now what about fecundity? Which stages can reproduce and contribute to stage 1? Well, only stages 3 and 4. So there you go. I've gone through 3 different examples, and you should be able to go both directions. From a life cycle diagram to a transition matrix, and from a transition matrix to a life cycle diagram. And now we'll see how far we can get in actually describing the mathematical model that we'll use for lays and albatrosses and midway atoll. Okay, so again, we'll go through these 6 stages. Asking the research question, making assumptions, developing the conceptual model, formulating the mathematical model, assigning values to parameters, and using the model to actually answer your research questions. So the research question Myra had was, how does lead poisoning of chicks affect population growth? And will lead remediation, or removing this lead poisoning, or at least reducing it, help protect the population in a significant kind of way? So again, these are the assumptions that we made. And of course the key one is that all individuals in each stage are identical. Now we're to develop the conceptual model. You usually have to do this based on the life history of a different organism. But let's learn a little bit about the life history of albatrosses by watching a video that I put together from videos different friends have made at Midway. You might want to turn down your volume now because it's a little bit loud. So here's what it looks like at Midway from about December to August. This is what their courtship looks like. And about December, January, February, you see what's going on everywhere. And then about January, the adults lay an egg. Egg hatches in about February, March. And then you see the parents coming back and feeding their chicks by regurgitating. It was mostly squid eggs. Mostly squid or flying fish eggs. The birds grow up, the chicks grow up, start losing their down, they get really funny haircuts. They start becoming a little more mobile, where they can look for shade on a hot day. And then they have to learn to fly away. This is what I actually do. Yeah, baby, fly! Get out there! Get past these white chicks! Fly, fly, fly! And then they spend between 3 and 6 years at sea before they actually come back and look for a mate. And then maybe another year or 2 before they actually find a mate successfully and lay an egg themselves and raise it successfully. So they're not actually completely a full adult with breeding successfully until they're maybe about 8 or 9 years old. Okay, so the first stage is going to be the eggs. And we're using 10/5 of the year, so really this is from eggs to a year old. So it also includes chicks, includes chicks. And then stages 1, 2, and 3, or years 1, 2, and 3, are juveniles. Well, they're out at sea for several years before they even come back to land. And then the next couple years, they're kind of pre-adults, they're immature, that are looking for a mate. And then 6 and 8, maybe they found a mate, but they're not really quite breeding successfully yet. And then 8 and above, they really are able to mate successfully. They might skip a year here and there, but they're usually able to mate successfully and actually stay with the same mate unless their mate is lost, as far as we know. So for our model, we're going to have 9 different stages, E, in years 1 to 8. And stages E to 7 can all grow into the next stage. Only stage 8 can persist because, well, you can't be an egg or a 4-year-old for more than 1 year. However, this is really stage 8 and above. because they pretty much have the same rate of survival and reproducing once they get to be about 8. And only stage 8 can reproduce. So this is a mix of an age-based and stage-based model. From here to here, it's all age-based, but then we've combined all ages 8 and above into this stage. And remember, wisdom is what, like 63 or something? So these birds can live for a long, long time. They can have a really long mortality, and they can have a whole lot of babies. Okay, so now let's start with this conceptual diagram, this life cycle diagram, and build the mathematical model, the matrix. So as I said, all of the stages except 8 can grow into the next stage. But for each of these categories, they're going to have the same growth probability, which is probability of surviving and growing into the next stage. So the probability of ease surviving and going into stage 1 is G1. The probability of stages 1, 2, and 3, the juvenile stages, of surviving and growing into the next stage is GJ for juvenile. And for immature stages 4 and 5, they have the same probability of surviving and growing into the next stage, GI. And then our sub-adult stages, 6 and 7, have the same probability of surviving and going into the next stage, or GSA. Of course, stage 8 can't grow into the next stage because it is the terminal stage, so it doesn't have a G. However, only stage 8 has a P value, a persistence value, for surviving and staying in the same stage. And only stage 8 has an F, or fecundity, of contributing to the first stage, which in this case is E. Okay, so now we need to put this into a mathematical model. And for this, I'm going to go out to PowerPoint. Okay, and we're going to use these possibilities over here. So take a minute and see if you can do this on your own. Okay, so let's move this so you can see it. So these are the different parameters that we're going to put into our mathematical model. So let's put in the G's first. The probability of surviving and staying in stage E is not possible, right? Because you can't be an egg for more than 1 year. And the same for all these other stages. You can be a 1-year-old, 2-year-old, 3-year-old, 4-year-old, 5-year-old, 6-year-old, 7-year-old for more than 1 year. However, you can't be an 8-year-old for more than 1 year. Or you can be 8 and above for more than 1 year. So we'll put that key age right here. Okay, so now let's do the diagonal just below that, which is our G's, right? And the probability of surviving from an egg to a 1-year-old is this G1. So that's from E to 1. So it goes right there. And the probability of growing from 1 to 2, 2 to 3, 3 to 4 is GJ. So that goes 1 to 2, 2 to 3, 3 to 4. The probability of growing from 4 to 5 or 5 to 6 is GI. So let's get that. 4 to 5, 5 to 6. And the probability of going from 6 to 7 and 7 to 8 is GSA. And then the only one of these that we haven't looked at so far is fecundity. So only one stage can reproduce, which is stage 8 and above. Okay, well let's see if we get that right. Yep, so now we can fill in zeros everywhere, except for the stages that definitely have a non-zero value. So in your lab, when we ask you to fill in the matrix, you can just turn in something like this, where only the non-zero values are indicated by a symbol, like a G, an F, or a P. In some cases it gets a little bit more confusing than that, but you don't have to actually put in numbers, so you don't have to write in all the zeros. I'm totally okay with that. But just so you know that all the empty ones are zeros.